Hi, welcome back. This is the section called Cryptology, and in particular, we will be learning about ciphers. So first of all, we need to define what cryptology is, and then in particular, what ciphering is. Cryptology is the study of the process of securing information or written text through the use of mathematical algorithms to make the original information hard to decipher. In Greek, the word kryptos means hidden or secret, and graphia means writing. So cryptology means secret writing, the study of. So the difference between a cipher and a code. These words are sometimes used interchangeably, and they shouldn't be. For instance, a cipher is actually mapping symbols, could be letters, to common letters in the alphabet. So for instance, I could say a star equals the letter A. A code is when we take a sentence or several words and shorten the meaning of a single word or phrase. So for instance, maybe you and I have a secret code that if I type the emoji with the smiling emoji with sunglasses means meet me at the beach. So that's what a code is. So we're going to look at ciphers in particular. This is just an example of a cipher that I found online that deals with Sherlock Holmes. It's really cool. So here's a few examples that we're going to be looking at. The first one, Caesar cipher. The second one is PIGPEN, or the Masonic cipher. The Star Wars cipher, and Morse code. So there are several steps of encoding or ciphering a message. One, you write your message in plain text. That's readable text. That means, what is your message? And then I'm going to choose a cipher to encode the message. This is called encryption or enciphering. Some ciphers have a key or keyword that increases security that may be used in the process. I don't know if you notice there's a little locked, it's a locked lock in the corner when you go to buy things online. That means it has a key that increases security. And after the message has been encrypted, the hard to read result is the cipher text. Okay, so once we have our message enciphered, the next steps would be for the other person to decrypt it. This is called decrypting or encrypting the message. So if a keyword or a key was used, you're going to need that information. You have to try to figure out an algorithm to decrypt the message back into plain text. If you know what the cipher was, the algorithm is easy to figure out. Some methods of attacking the encrypted message will be discussed, as well as we'll look at examples of historical ciphers. Attacking an encrypted message means you don't know what the cipher is and you're trying to figure out what the cipher is saying. Okay, so the first one we're going to look at is one of the easiest ones to understand. It's called the Caesar cipher. It's named after the famous ancient Roman Emperor Julius Caesar. It is a simple monoalphabetic substitution cipher. Monoalphabetic means one letter maps to another letter. It's also called a shift cipher. It was used for military communications, and it was pretty good for a very long time because most of the people that Julius Caesar ruled were illiterate, so they thought it was another language. And we're going to encrypt a quote by Julius Caesar so you can see how this works. And the quote is, "I came, I saw, I conquered." Okay. So usually in cryptology, we take our plain text and we write it in lowercase letters. So I wrote the plain text message, "I came, I saw, I conquered," in lower cases. And then here below it is the cipher text of our message, which reads L, F, D, P, H, and that should be a comma, L, V, D, Z, comma, L, F, R, Q, X, H, U, H, G. So our ciphered text message, if you notice, is in uppercase letters, and they are all capitalized. Okay, So the Caesar cipher, I can let you know, is a shift cipher. Shift means we literally take the alphabet and we shift it. In the Caesar cipher's case, it was originally shifted by a unit of 3 to the right. So if we look at our screen, and I don't know if you can see my little arrow, I'm hovering over the letter A. A is now going to map to D because D is 3 letters to the right of A. So A equals D, B equals E, C equals F, and so on until we get to Z. Now, I think you can notice that Z equals C because we wrapped around the alphabet. Okay, so that's a shift of 3. Below it is a Caesar cipher shift, and it's a ring. So if we look at the ring, once again, A maps to D, B maps to E, C maps to F, D maps to G. I like the cipher ring. You can find this online, by the way, and you can make your own ring, which is kind of fun. Okay, so let's look at the next slide. So the Caesar cipher and modular arithmetic. So in the last section, we talked about modular arithmetic, or mod. This case, because we use 26 letters, is mod 26. So the letters have to be set up. We're going to set up our plain text alphabet with the corresponding letters of 0 to 25. Why don't we use 1 to 26? Can you guys think of a reason why? Hopefully you said that 26 mod 26 was 0. So I have to show 0 in some manner, and 0 maps to A. So we have 26 letters. Just remember it's modulus addition. So that's why we use the values of 0 through 25, which is actually 26 numbers if you think about it. Okay. So because the Caesar cipher is a shift cipher, we need to show that the 3 letters shift to the right when we encrypt the message as mod 26 plus 3. Okay, so what we're going to do is we're going to take every single letter, assign it a number, which we already did, and then we're going to add 3 to that. Okay, so right now, you can see A is mapped to 0. This is plain text. B is mapped to 1, C is mapped to 2, etc. So if I take this quote, also by Julius Caesar, experience is the teacher of all things, and I turn it into plain text numbers. So I look here, experience, that's an E. E maps to 4. So I write down 4. X maps to 23. So I write down 23. P maps to 15. So I write down 15. E maps to 4, so I write down 4. R maps to 17, so I write down 17. I maps to 8. E maps to 4. N maps to 13. C maps to 2, and E maps to 4. And I continue this process until I have the whole thing encoded. By the way, I've encoded this into numbers, right? But it is still the plain text. So to show the Caesar cipher shift, if I want to encode my message, and even if I want to break it, what I do is I add 3 to every single value. So remember, this first word was experience. So my first number was 4. So if I add 3 to 4, I get 7. If I add 23 plus 3, I get 26. If I add 15 plus 3, I get 18. If I add 4 plus 3, I get 7. If I add 3 to 17, I get 20. If I add 3 to 8, I get 11, and so on and so forth. So I took the whole message and added plus 3 because I shifted the alphabet to the right for the Caesar cipher. So now my message looks like this. 7, 26, 18, 7, 20, 11, 7, 16, etc. Before I go on, I want to make sure I don't have any values larger than 25, because it can happen. So if I look through in the first word experience, that X turned into, now it was 23, now it's 26. So remember, we only have digits from 0 to 25. So we need to take the modulo 26 of that number. So what do? I take 26 mod 26, and what is that equivalent to? Hopefully you said 0. So now 7, 26, 18, 7, 20, 11, 7, 16, 5, 7 turns into 7, 0, 18, 7, 20, 11, 7, 16, 5, and 7. So the 26 became a 0. The other ones are fine because if I look through the other words, they are numbers less than 25, so I don't have to do anything to the rest of them. Okay, now what? So if we look at this, 7, 0, 18, 7, 20, 11, 7, 16, 5, 7, etc., we can write the message using that text. So what's 7? 7 is H, so E turns into an H. Remember, this is experience, right? X turns into A. P is now going to be 18, which is S, okay? All right, so to decode or to decipher the message, you use mod 26 and you're going to subtract 3. So you know that message that we were working on there? If you did the whole thing, all you would have to do is subtract 3 from each value, and then you get the table, and you can use the table below. So here's the table below with a shift of plus 3. So remember I said A mapped to 3, E mapped to 7, etc. Okay, so that is a Caesar cipher, and I talked about modular or modulo arithmetic. So you guys have seen that before, and that's a connection between the two. By the way, the use of modulo arithmetic will allow me to decode the Caesar cipher. There are other ways to decode it as well that we're going to discuss at the end of this video. The PIGPEN cipher, that's also known as the Masonic cipher. It's a really, really cool cipher. It's also a substitution cipher, just like the Caesar cipher. However, it is monosymbolic. Monosymbolic means taking one symbol and mapping it to a letter or number. It was used by the Freemasons, which is a group that is still around today, but it was used by them in the 17th, 18th century. The start of the origin is unknown. They think that it at least goes back to the 18th century, and that's why I said it may have been used in the 17th century as well. It was used initially to keep the Masonic records of history and rites private. So if you were a Mason, you didn't want someone else getting into your information. So what they would do is they would use a cipher to write out all of their meeting minutes, their records, etc. It was also used to communicate between the lodges. So let's say I have a lodge and I'm in St. Petersburg and I want to talk to the lodge in Tampa. Back then, they would take and write out whatever they wanted to say in cipher text and then send it to the other person who knew how to read it. It was also used by others, the Rosicrucian Brotherhood, George Washington's army, Revolutionary War, and Union prisoners during the Civil War. I do want to also point out that it has been used in modern times. There are quite a few stories of people writing even books in PIGPEN cipher that hide a secret treasure. So it's a really interesting cipher. And it was considered unbreakable for at least 100 years. No one was able to decipher it. They thought it was like an alien language. And I don't mean aliens from the sky, just alien meaning not native, foreign to the area. Okay, so this is what PIGPEN cipher looks like. Here's a message encoded using the PIGPEN cipher, and it looks like this. So see what I mean by it looked foreign? And that's why people were like, I have no idea what this says. Okay, I can tell you it is monosymbolic. So each symbol equals a letter, usually, or a number. And this is what the PIGPEN cipher looks like. So if I want to get A, for instance, and I'm going to take my cursor here and go over this, A is going to equal, it looks like a square, but you're only going to draw the right-hand side of it and the bottom of the square only. If I were to write E, it would be the whole entire square. If I wanted to write down the letter T, T is just going to be the left-hand side of this X. So where I'm kind of going over here. If I want to write out an N, I would put a square and then I would put a dot in the middle or in the bottom of it. Okay, so let's look at our message again now that we know what the cipher key is. This symbol here is X. So if I look over here, X is the left-hand side of the X with a dot in it. Whoops, sorry guys, let me go back there. So we can see that it's the left-hand side with a dot in it, that's X. M is, it looks like a square with the top, the right side, and the bottom with a dot in it. Does not have the left-hand side. You guys see that? A is a right side of a square in the bottom, and R, and etc. So we can see that the text gets basically, rearranged, and we use the PIGPEN cipher to encode it and also to encode it. Okay, so I found a couple of interesting things that you guys might enjoy. This is an image of a tombstone that is near the Trinity Church in New York City, and it makes quite a stir because it is the only tombstone that has PIGPEN cipher on it. And the person who is buried there, whose tombstone that is James Leeson. By the way, back in those days, they made an S that looks like, yeah, it is an S, but it looks kind of like an L or an F even without the middle. So I just wanted to point that out. But at any rate, here is his grave, and as you see on the top that I'm hovering over, this is PIGPEN cipher, a variation of it. He was also a Mason, and how do I know that? Because if I check out this portion of his tombstone, it has symbols of the Mason Lodge. There's a compass here, there's a T-square, etc. And where I got this information from is a site that I like. It's called Atlas Obscura. And we're going to click on that, and hopefully this works. So there's a whole article about this particular Manhattan tomb. And it talks about the cemetery near the Trinity Church. It shows his tombstone, and it talks about some of the symbols on here as well. So it's a really cool read. But the thing is not too many people know anything about Leeson. We know he was a Mason, and that's about it. So, yeah, I just wanted to show you that. And, once again, this is on Atlas Obscura. Kind of a fun place to look. And below it shows how to decipher it. So, if we go back up here and look at his tombstone, it actually reads, "Remember Death." I guess that's appropriate to be on someone's tombstone. Okay, so back to the PowerPoint here. Like I said, you can click on this and play around on the website all you want. Just pause me and go look at it. So here's the next page. There's other examples that use the PIGPEN cipher, and here is a link to a website that gives several more interesting examples of the use of the PIGPEN cipher. I will provide all of these links to you on Canvas, so if you want to just for your own interest, you can go look at that. But I really like this site. It may be in German, just to forewarn you. All you have to do is hit translate this page in Google. But there's even a tale on there about a pirate holding a treasure map, and he was hung, and he threw the map out to the people, and I guess it was encoded using the PIGPEN cipher. And he said that it led to his treasure, but no one can decode it, and his treasure was never found. So maybe you'll be the lucky one. I don't know. All right, so the next cipher that we're going to look at is called the AUREBESH cipher, and it's also known as the Star Wars cipher. So if you're a Star Wars fan, hooray for you, and you'll probably be excited about this. But there's a cipher that's used in the movies, and it is also used in the attraction located at Walt Disney's Hollywood Studios called Star Tours. So if you've been on that ride, you may have seen the cipher text written as you wait in line to go on that particular attraction. So it was created by Joe Johnston, and it was created for the original trilogy. And the interesting thing about Joe Johnston was he was a special effects artist. He worked on Jumanji, by the way, and Jurassic Park. He is now a director, but he's the one that created the font that is known as the AUREBESH cipher. So here's an example, not a great picture, but here's a picture nonetheless from that ride, Star Tours, at the Walt Disney World Hollywood Studios attraction. And what the ride is basically you're trying to get on a transporter and you're trying to go someplace. So while you're waiting in line, it kind of is supposed to be like an airport, but it's a space airport. So you get to see C-3PO and R2-D2, etc. But anyways, there's a sign and it said destinations, flight time, and status. So the destinations and the status is written in this AUREBESH cipher, and it actually says something. So let's look at the next example here. Here's the AUREBESH cipher. So for instance, A is that funky symbol here. O looks like an O, so that one's kind of nice. T looks like an upside down T, so that one's easy to recognize. So let's check this out. So I placed on the example of the departures, and I also placed on the AUREBESH cipher next to it so that we could see that. And if you want to, all I'm going to do is translate this first row. So check it out, try to translate it yourself, pause me, and see if we come up with the same answer. So if you look at the first row, the destination turns into Tatooine, which if you're a Star Wars nerd like me, you know what that is. The flight is 7:12, the time is 7:45 in the morning. The status, which is written in the AUREBESH, translates to gate change. And you're now at gate 27. So just kind of fun thing that we can use the AUREBESH cipher for. And there's a previous example that I had when I had up the cipher page of the different types of ciphers we were going to look at in Ciphering Part 1. And if you look at this is actually from the Star Wars edition of Monopoly. And I'm going to let you translate this bottom line here. Whoops, let me go back. Sorry about that, guys. So go back to the bottom and translate this and see what this says. Like I said, it's kind of fun. Okay, Morse code. It is not a code, but a cipher. So it should have been called the Morse cipher, but hey, everybody today calls it Morse code. It is still in use today to transfer messages via radio, light, or knocks on the wall. Some of the kids, I don't know if you've seen Stranger Things, you know, they're in the AV club, and you know, if they want to send a message, they might use Morse code. So it was created by Samuel F.B. Morse, who was the inventor of the telegraph. So this kind of makes sense. It contains dots and dashes. Some people call them dits and dahs. Okay, so a visual and an audio message in Morse code. The top by this bullet point is in Morse code. It translates into "What hath God wrought?" And that was the first message sent by Morse code by Mr. Morse. So that's why I put it in there, because I thought that was a really cool little fun fact of trivia. There's an audio example of Morse code as well. So let's go ahead and check it out. Okay, so here we go. This is SOS in Morse code. Okay, so we want to hear that again. Once again, this is SOS in Morse code. Okay, and we can write something like, hello, how are you? Let's hear what that sounds like in Morse code. That was actually SOS, sorry. Let's try that again. Hello, how are you? Okay, I don't know if we can play this. Let me try. Okay, so that is hello, how are you in Morse code. Pretty neat, right? So I'm back on the PowerPoint, and if you want to play around with that Morse code, like putting a message in, seeing what it sounds like or what it looks like in Morse code, I put the URL link in this PowerPoint presentation. I will also attach it to Canvas as well for you. Okay, so Morse code, here is an actual visual representation of all the letters and numbers and punctuation in Morse code. So if you look at S, because we did SOS, S is 3 little dots, and then O is 3 long dashes, and then S again is 3 dots. So it's dot, 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 dash, 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 dot, dot, dot. Okay, so I don't know, a bit of trivia here. The Titanic tragedy was the reason why we use SOS today. Basically, what happened before the Titanic tragedy was the Macaroni Ship Company decided that the way to signal a ship was in distress was to use the letters C, Q, D. Some people claim that CD or CQD meant come quick danger, but that's not actually true. The CQ means, hey, stop any further communication via Morse code, you need to listen to me, and the D means distress. So the operator of the Titanic did use CQD, and it was very confusing for the other boats. They didn't know what was going on. And after the trial of the Titanic happened, they started using SOS, and it's still in use today. So I have a website that's really interesting if you're interested in the Titanic tragedy and what happened that day. So we're going to go to the BBC. It's a really good source of information. So here's a magazine article about the Titanic, the final messages from the stricken ship. Before the ship went down, you know, the operator, the Morse code operator was like, hey, you know, he was putting out messages to people back in New York like, hello, boy, dining with you tonight in spirit. Hearts with you always. Best love, girl. You know, things like that. Hey, no sickness. All is well. Notify all interested in poker. You know, so they sent out a Morse code. By the way, these messages were extremely expensive. So I'm imagining there's the first class passengers sending trivial messages back to the homeland. But after it struck the iceberg, now the Morse code operator had to write out, come at once, we have struck a berg. It's a CQD, old man. So you see that CQD, once again, that means, it does not mean come quick danger. It means, hey, stop communications. Our ship is in distress. Okay, so I just, thought if you were interested, go ahead and look at this article because, like I said, it's pretty interesting, or at least I find it to be interesting. Okay, so that is the use of Morse code. And now we're going to talk about breaking a monoalphabetic or monosymbolic cipher. So basically, we can understand that we can do quite a few things to break these. They're actually very, very easy to break because there's a couple ways that you can do it. You can do the brute force approach, basically saying, okay, I don't know what symbol this is, but let's guess. Maybe this equals A, and try out A, and then maybe it doesn't equal A, maybe it equals B, and then maybe it equals C. But that's going to take a little bit of time. More often than not, we use frequency analysis to be able to break these monoalphabetic or monosymbolic ciphers. And we're going to learn what frequency analysis is in a minute. But it kind of has to deal with Wheel of Fortune, believe it or not. I don't know if you guys watch that show, but my grandmother used to watch it extensively. And when I was over at her house, she had it on, and I'd watch it too. In fact, I like the show. But the person who won the rounds would go into their final round, and they would win fabulous prizes like a car or a trip someplace nice like Hawaii. But if you noticed, when they had that final round, the puzzle came up on the screen, and the letters RSTLNE came up immediately. And then the contestant had to pick, I think, 3 more consonants and another vowel. So these letters, RSTLNE, the reason why they come up on Wheel of Fortune right away is because RSTLNE are used 45% of the time in the English language. So if I write out a whole page of information, or even if you look through my PowerPoint, you'll notice that the most popular letters are RSTLNE. So that's what's called frequency analysis, seeing how frequent a letter is occurring, or frequent how something's occurring. So the following list shows the percentage of time the following letters are used in the English language. The most popular letter in the English language, which occurs 12.7% of the time, is E. One of the least popular letters, and I'm sure you're not surprised, is Z, which is 0.1. Okay? So if I know this information and I have an encoded message, whether it be monosymbolic or monoalphabetic, if I see the same symbol occurring quite a bit, I can guess it probably is E or a T. So here's a frequency histogram. So if you take statistics, you'll definitely run into this. I also talk about this in MGF 1106. A histogram is a bar graph where the bars are touching. Do you guys see how all the bars are touching here? And basically what this is showing, it's showing the letters of the alphabet on the x-axis, and on the y-axis, it's the relative frequency. This is in decimal, so if you turn it into percent, you would take decimal 2 places to the right. So if we look at the letter E, we see that's the highest bar on here. And we see that it's in between 12 and 14. Remember from the last slide, and we can pop back there really quick, E occurs 12.7 times. So if we look at this, this is about 12.7% of the time we'll find the letter E, and so on and so forth. Our next popular one is T. By the way, we didn't mention this letter before, A. A actually occurs 8% of the time, so it's pretty high. But remember, on Wheel of Fortune, you're only allowed to have one vowel right off the bat. So if I was a contestant, I would definitely pick the letter A. That would be a really good choice. Okay, the other thing that is useful to know if you're trying to decipher or decode something is common bigrams and trigrams. So bigrams, bi means 2. So common pair of letters are TH, EA, OF, TO, IN. It, is, be, as, at, so, we, he, by, or, on, do, if, me, my, and up. Common repeated letters are SS, EE, TT, FF, LL, MM, OO. And in fact, when we looked at that word Tatooine in the Star Wars cipher, Tatooine had 2 O's in a row. So that's not an uncommon thing. We also have common triplets, which are called trigrams. Tri means 3. And common triplets would be the, EST, for, and, his, ENT, and THA. If you notice with the bigrams and trigrams, these can be complete words, or they can be word endings, or in the middle of a word. Like for instance, the happens quite a bit in codes. So if you see a 3-letter grouping, you could see if it's the. Okay, and that'll give you a hint, because now if you know it's the, you know 3 letters already. So there's a website with more information about bigrams and trigrams, etc. It's actually, the site's called Practical Cryptography, Crypto Analyst. So let me stop this and take you there. Okay, so I tried clicking on this and for some reason my internet is not working on this site, so I don't know if the site is down or if there's some issue. But at any rate, what it basically showed you was and let me like click on this and show you, it showed the common bigrams and the percentage of time they occur, and the trigrams. They even had, I think they called them quadgrams, but four word combinations, and they also show the letter frequency histogram. So that's what that site shows. So hopefully, you know, by the time you're watching this, it works okay. If it doesn't, sorry about that. I mean, it's okay either way. All right, guys. Well, that is it for now. So that is ciphering part 1. Make sure that you have taken notes on this entire video. For instance, really pay attention to definitions. You know, what is the cipher? How does it work? You know, what is frequency analysis, etc. You will have a handout that goes with it that is homework that you have to do, and it basically will ask you information contained in this PowerPoint. So thank you, and we'll be doing part 2 soon. Have a good day.